Windtopia has been integrating their global operations with OSI Soft Cloud Services. After aggregating, contextualizing, and analyzing their data, they are now ready to enable additional stakeholders and consumers. I'm going to show you first how to configure an OCS data view, and then how data views can be utilized to share data with different business partners and to enable data scientists with applications like Microsoft Power BI and Jupyter Notebook. Before diving into data views, let's remind ourselves of the data that we're working with. We're starting on the homepage of the OCS Customer Portal, and I'm going to click on the navigation menu to go into the Asset Explorer. Since we're going to use data views to perform further analysis across the different wind turbine assets, let's pull one of these up and take a closer look. The assets we're interested in are called GE01, GE02, and so on. Here we're looking at GE04. Opening up the details on the right-hand side, we can see that there is a lot of data on each of these assets. We have 13 metadata items and over 100 unique properties. But for our use cases, we need more targeted sets of properties, not the data for the entire asset. So to form this data set, we'll now go configure a data view. Using our navigation menu again, we'll scroll down and choose data views this time. Here we can see the list of data views that currently exist. I'm going to start by scrolling down and editing one of the existing data views so that you have a better idea of what the end result will look like. This is where we both configure and preview the data set we're creating. A data view is really a configuration. It's not a static set of data. Rather, you are able to resolve the data view configuration and request its data when you need it. On the left-hand side of the page, we have the configuration, and on the right-hand side, we see the effect of changes to that configuration in the preview data table. Starting at the top of the configuration, we have the data view information, which includes a name and description. Then we have a section called the index configuration. Data views align different fields across the same index. So in this case, we're looking at a date time, and we provide a start and end time range and an interpolation interval. Then we have the list of data fields actually included in this data view. First, we have the timestamp, since we are aligning on that index, and we can see this represented in the first column in our table. Then we have a grouping field that helps to organize the data and provide additional context. This field is set to the asset name, and you can see this in the second column of our table. Finally, we have our individual properties or fields. But how do we get the data in here to begin with? Well, in data views, it all starts with a query. So I'll show you how to manage the underlying query for this data view by clicking on Manage Queries. You can query for either streams or assets to include in a data view. And you can even create multiple queries in a single data view if you need to include both. The query in this case is searching for the asset name. So GE star is returning 16 different turbine assets. An important thing to keep in mind here is if I make my query criteria flexible like this, and then if I add a new asset like GE17, which meets that criteria, this data view will now include that new asset automatically the next time we ask for data. So I'm going to keep the query as it is with these existing 16 assets. So I'll cancel out of this and head back to the configuration page. We've already narrowed in on a set of interesting fields to include in this data view, but there are a few more pieces of information that it would be good to include. So I want to start by adding a metadata field. So under Field Management, I'll click on the Add button. I want to add the wind farm metadata. So I'll start typing that in, and we'll filter our list down to the specific piece of data that I want. I can select this and then click Add. Now over on the left-hand side, we'll see that this updates and the wind farm was added to the bottom. I'm going to go ahead and move this to the top, just because I like seeing the static information and the context first. So once we've applied that, you'll see that the wind farm information for each of these turbines now shows up in the third column. I also have this active power value field, but instead of just having the interpolated value, I'd really prefer to have the average for these intervals. So I'm also going to add a new field to capture that. Clicking on our Add button again, I'm going to select the summary type that I want to include. I do have other options like minimum and maximum and such. So we'll go ahead and select mean, and this will start to filter the list below again. And I'll kind of scroll down here and see active power value mean. So this is the new summary that I'd like to add. So once it's selected, I'll click Add at the bottom. And this will get added to our list of fields. So now we have the original active power interpolated value column, and the one to the right of it is the mean for the interval ranges according to the intervals that we already set up in our index configuration. And then I also want to make sure that we have units of measure for our different properties so that end users know exactly what they're working with. We do have two different ways that you can add units of measure in data views. First, you have the option to include the unit of measure in the label. You can see this in our active power value kilowatts. This comes from our labels, which are dynamic and include tokens that update and can be filled in dynamically as the information is included. You can go in and modify these labels by clicking on Edit. Now, the other way that you might want to use units of measure is if you have cases where all of the data in one column may have different units. So I'm going to show you that with our temperature properties. So I'm going to select our bearing A temperature and our bearing B temperature fields, and then click Edit. Here I have the opportunity to go ahead and check the box for Include UOM field and apply that. Once the preview loads, you'll see that we have two new columns. These were added directly to the right of the original bearing A temperature and bearing B temperature values. And now when I scroll through and see the different data for each of these turbines, I won't be worried if perhaps we go from degrees Celsius to degrees Fahrenheit, depending on how the data is being collected for assets in different regions. One final feature that I want to point out is a quick way to pivot the data view. So I'll scroll back up to the top of my configuration under the name and description and look at this data view shape toggle. So far we've been using the standard format, and that basically means that we shape the data so one measurement or property maps to one column. But a common alternative is to pivot this table so that you end up with a more generic schema. We call this narrow mode. So once we update and apply this to the preview, we'll see that we end up with a much more generic set of column headers. This includes timestamp, name, field, value, and unit of measure. And as you scroll down, you'll see that the fields change and include each of the individual properties from before, but in a different format. So I'm going to go ahead and revert that because we will be using this data view in our other applications. And then we'll go ahead and save. Once we have the data set in place that we need for our next set of analysis, we can move on to actually using that data. And we'll do that through the OCS REST API. One of the tools that we provide in the OCS portal is called the API console. It's pretty useful for getting to learn the REST API and the different resources within OCS. Heading back to our navigation menu again, we'll scroll down to the bottom under Developer Tools, click on API Console. We're going to use the Type Ahead help to navigate to the data view that we just created, and I'll show you how to form the right request to get data from it. So if I go ahead and enter a slash, I'll be able to choose the right namespace that we want to be in this case, production. Then I can choose the collection of items that I want to look at, in this case, data views. And now I can scroll down and find the data view that we want to work with. And now I can insert the rest of the parameters needed in order to request data for this data view. Now we'll provide a start and end index and an interval. And I'm also going to add a form parameter here so that we can get this back in a nice, easy to read CSV format. So now that that came back, you can see we have the columns just like we were looking at in our preview table with a subset of the data coming back as well. Now that we know how to get data through the API, we can look at how to share that with other consumers. Now, before we get to those other applications, I want to show you our GitHub samples first. This is a really good resource and a great place to start if you want direction with integrating to OCS. On our GitHub page, you can find a number of different samples for a variety of tasks like authentication, data ingress, and a few specific integrations, one of which is a sample Power BI connector. This sample takes care of authentication with OCS and also allows users to input requests for OCS data. And I point out this sample specifically as it was utilized to get data into this Power BI report. This Power BI report for Wintopia includes a few examples of how they have enabled different personas with data views from OCS. The Overview tab is for stakeholders looking at the bottom line and at the impact of production on revenue. The next two tabs are targeted at our OEM turbine vendors who monitor the operations of their respective assets looking for potential issues. Wintopia can use the metadata in their assets to create separate data views for each of these different vendors. So as we see what's possible in Power BI, remember we're enabling this application and these personas with data from OCS that's been shaped for easy consumption through OCS data views. Now, if an engineer or operator finds something interesting in the dashboard, they may loop in a data scientist for additional analysis. She might continue with exploration in Power BI, or she could jump into a tool like Jupyter Notebook. Here we have a sample notebook showing some common ways of working with data in Python. The first thing we need to do is authenticate with OCS. Not only can users log into OCS via different identity providers, but you can also set up different client connection methods depending on the type of application and user involvement. Once I'm authenticated using my client secret, I'm ready to access the data view we just created. Then we request the data for it, and we'll immediately load that into a Pandas data frame. Now we can do correlation analysis, look at individual trends, and look for patterns in the data. I could even start training a machine learning algorithm and share my notebook with colleagues to collaborate. If you want to learn even more about using Jupyter Notebook with OCS, we offer a learning course called Enabling Enterprise-Wide Data Science with OCS Data Views. To wrap up this demo, let's recap what we learned. First, we created an easy-to-consume data view to share with colleagues and applications. This included data for 16 turbines. Metadata, properties, summaries, and units of measure were brought together to form decision-ready data. Then we learned how to navigate the OCS REST API with the API console and formed the API request for our data view. Finally, we saw how applications like Power BI and Jupyter Notebook can access OCS data and enable stakeholders and data scientists.